Pressure in fluids. In physics, a fluid is a substance that continually deforms or flows under an applied external force. Fluid is a state of matter that can flow because of less intermolecular force of attraction inside the matter. Using these definitions, we can say that liquids and gases are fluids. Fluids do not have their own shapes and take shape of the containers in which they are placed. For example, water is a fluid. As the water flows along a river, it constantly changes its shape to fit the space available. If you pour a liquid from a glass onto a plate, the volume of liquid stays the same, but its shape changes. One important feature of fluids is that they exert pressure on the walls of the containers they are in. All fluids exert pressure because their particles are constantly moving and bumping into things. So, let us repeat what we know again. Matter occurs mainly in three states: solids, liquids, and gases. Liquids and gases together are called fluids. The main difference between solids and fluids is in terms of pressure, especially internal pressure. We have seen in earlier videos that pressure is equal to thrust upon area. A solid exerts pressure only on its base downwards due to its weight, while a fluid exerts pressure at all points in all directions inside because the molecules have inherent internal kinetic energy and move around. Let us briefly look at one of the main properties of liquids, namely pressure exerted by liquids. What we discuss here is also valid for gases, but we may discuss in detail about properties of gases later in higher classes. Pressure exerted by liquids can be seen with the help of some simple experiments. Take a bottle and create 3 holes at different heights. Pour some water in the bottle. You will observe the following. Water streams out through the holes. This shows that water exerts pressure. The water stream coming out of the lowest hole reaches the farthest. This shows that the pressure exerted by liquid increases with depth. If you create holes at the same height, you will notice that the water stream comes out evenly, irrespective of the direction of the hole. This means that the pressure is equal at the same depth. If you take bottles of larger and smaller cross sections, but cut holes at the same heights, you will notice that there is no difference between the strengths of streams coming out. This implies that the pressure exerted by liquid is independent of the size of the container, but depends only on the height or the depth of the liquid. We may now summarize what we have learnt about pressure in fluids. The characteristics of fluid pressure are: it increases with depth and only depends on the depth and not on the cross-section of the vessel. It remains the same in all directions at a given depth. In addition to these above characteristics, we may guess that the pressure in fluids creates pressure on the walls of the container, and the pressure will depend on the inherent properties of the fluid, such as the density of fluid. Before we end our discussions about pressure in fluids, let us discuss One fun fact. Why are dams built as wedge-shaped? Since the pressure in a liquid increases with depth, the pressure acting on a dam at the bottom of a reservoir is greater than the pressure acting near the top. This is why dam walls are usually wedge-shaped and they are thicker at the bottom of the dam. When you pour water or milk in a glass, what do you observe? You will observe that the liquid level is uniform on the surface. The surface of water placed in a container, a glass or a bathtub or a lake will remain at the same level. Adding water to one side will only make the entire level uniformly rise. There can never be one section of the glass or tub or lake that is at a higher level than another section. The surface of any liquid is always horizontal. So, why does a liquid seek its own level? To answer this question, remember two things. 1. Nature likes to equalize pressure. For example, air flows from a higher pressure region to a lower pressure region to equalize. This is how our weather system functions. The same can be said about liquids. Liquids flow to equalize pressure. And 2. Pressure inside a liquid depends on the height of the liquid. If you consider a point inside a liquid, if it is at a higher pressure, the liquid will move out from that point so as to equalize the pressure. One really good example of liquid seeking its own level can be demonstrated using a communicating vessel. A communicating vessel is a system of differently shaped vessels that are connected at the bottom. You can see that if you pour water or any liquid in such a vessel, the water level in all sections of the vessel is same. Liquid seeking its own level has very many vast applications, and we may discuss these in later videos. But for the moment, let us pause here by giving you some food for thought. Can you guess why a spout of a plant watering can is always longer than the height of the can? And the same question can be asked about a teapot as well. Hint: think in terms of liquid seeking its own level.